All right, guys, so today we start a new unit. We start our unit on graphing, writing and graphing linear equations. So before we get into that, you do need to know what the parent function is. Parent function meaning the beginning, the origin, right? So this is basically, this straight line here is basically our starting point. Now we're not going to do a lot of writing on this handout. It's more just for reference. Parent function. This is the starting point. Meaning before we make any kind of changes, that's supposed to be a parenthesis. Sorry, looks weird. It won't let me draw down for some reason. There we go, starting point. Now the equation, the starting equation is y is equal to x. Nothing in front, nothing on the side. So if we were to draw, or if we were to write that equation with numbers inserted into it, what kind of coefficient can we give a variable without one? We put a 1 in front, right? And since it doesn't have anything added to the side, it's considered 0. The 1 representing our slope, the 0 representing our y-intercept. Our y-intercept, right? Meaning every parent function, every parent linear function, straight line, going through the origin. Before we can change any of these numbers, we need to know where to start. It's a line that's going straight up from left to right, going through the origin, and slope is 1, meaning we go up 1, over 1, up 1, over 1, up 1, over 1, right? You don't have to write that part. Now, on a parent function, our y-intercept is 0, 0, the origin. Our x-intercept is also 0, 0, going through the origin. Now the domain, remember when we were talking about domain and range, we're talking about how far to the left, how far to the right does it go, or how far down, how far up. Let's not forget, let's go ahead and label the axis here. This is our y, and this is our x-axis. Our x-axis goes horizontally, our y-axis goes vertically. And the only other thing you're gonna have to write on this, the domain of the parent function is all real numbers, and the range is also all real numbers, meaning it's always going to go to the left, always to the right, always up, and always down. But remember, just for reference, the domain will be your x values. And yes, this is super tough writing sideways. And the range represents our y values, especially with this little machine. Y values. Okay? Now this is going to be one of the ones that we glue in first. Now the main part, since we're starting to get into graphing, the main portion of this lesson will be all of this vocabulary over here. So let's go ahead and get into that. All right, let me make this bigger, F11. Okay, I need to move this over here. Okay, I'm gonna zoom in a little bit. Hopefully I can see everything. There we go. Now, when you have the whole graph, or everything here that you see is part of a coordinate plane. And if you're just wondering how to spell anything, I'm grabbing the vocabulary words from over here, okay? So this is considered a coordinate plane. We're going to be labeling it coordinate. This is too thick. I'm going to make this smaller. This too much. Okay. All right. Now on our coordinate plane, let's start with our axis. We have our x-axis that is this thicker line right here. The x-axis that goes from left to right. Okay, now our negative numbers on the x-axis, it's like a numbered line. The negative numbers on this number line that's labeled the x-axis are on the left side. The positive numbers are on the right side. This is all just review. And on our y-axis, the positive numbers are at the top and the negative numbers are on the bottom. I'm gonna put a little minus sign for negative. Doesn't really look like one. Let me try that again. Minus sign. There we go. Well, that's ugly. Anyway, next thing we're gonna label says are our lines. Remember, we studied this already. This is our horizontal line. Probably should have gone with something different. Horizontal line. That is ugly. You can't make this perfect. Line. Here is our vertical line. So I'll try to write this as awesome as best I can. 4, 2, 4. There's our vertical line, and this one's just a diagonal. Yeah, it's going in a negative slope, but it's a diagonal. Negative. Why am I writing negative? I'm supposed to be writing diagonal line. Sorry. So sorry. I was going to do it again. This one was the hardest of all. Diagonal. That's our diagonal line. Okay. If you want to know how to spell it, it's right here. I've labeled the coordinate plane. I've labeled the horizontal, the vertical line, the x, and the y-axis. All right. Now, notice how this graph is split up into 4 parts. Each part is called a quadrant. Now, these are numbered counterclockwise. So this one would be quadrant 1. And they are labeled using Roman numerals. Quadrant 2. Here we have quadrant 3. And we have quadrant 4. Ooh, that's ugly. You guys are gonna hate me today. All I'm doing is a bunch of writing. Now 4 is written as IV, meaning 1 before 5. Now in quadrant 1, you're gonna find that that your x values are positive and that your y values are positive. In quadrant 2, your x values are negative, y values are positive. No, I'm not drawing faces. In quadrant 3, x values are negative, y values are also negative. And in quadrant 4, x values are positive, y values are negative. We are going to practice plotting points. This is my point right here. You can call it a point, you can call it a coordinate, whatever you'd like. Quadrant. Okay. Now, anytime you're going to graph a point, you always want to start here. This is the origin. And this is the origin right here, in case you're wondering how to spell it. The origin, the numbers here are 0, 0, which is why you saw a little 0 on your slope test. And let me see, what else do I need to label here? These, anytime your line crosses the x-axis, that is called your x-intercept. I'm just going to write x-int. This is another x-intercept. It is your vertical line crossing the x-axis. Vice versa, if it's crossing the y-axis, that is your y-intercept. Here we have that horizontal line crossing the y-axis, so that is a y-intercept. Think about intercept as intersection, right? Now here we have our ordered pair. This point is helping us locate where on the graph we have this dot, right? That dot is called a point. It can also be called an ordered pair. Ordered pair. For those of you wondering what I'm spelling right here, ordered pair. Or it can be also called a coordinate. Coordinate meaning showing you the location on the graph. Coordinates. Helping you find a location. Just like in geography, you use longitude and latitude. Now, this 3 is representing our x coordinate, or x value coordinate. And the -7 represents our y coordinate. These just help you find where on the graph, okay, you're going to find a point. Yes, we're going to fill all this in, so we're going to go kind of fast. Now it says the coordinate plane is formed by a horizontal number line. The horizontal number line is called the x-axis, and the vertical number line is called the y-axis. Each point on the coordinate plane has an address called the ordered pair. Ordered pair. Okay, the point where the axis cross is called the origin. The point where both of your x and your y axis meet is called the origin. The origin is 0, 0. That's the starting point. The x coordinate gives the location. Coordinate gives the location on the x-axis, and the y coordinate gives the location on the y-axis. Now, a linear equation with two variables has an infinite number of solutions. Infinite number of solutions. Okay? Each solution can be represented by a point on the coordinate plane. Okay? These points form a line. Now we're going to be practicing connecting the dots. These points on the line are going to create the graph of the equation. So if I tell you to graph this equation, that's what I'm talking about. You're going to plot the points and you're going to connect the dots, creating a straight line. Now I'm going to do a lot of highlighting here, so I'm going to pause the video. I just want you guys to be able to see. I don't know why this star is there. It's not even going to help us in anything. I want you guys to be able to see my axis and everything. So let me pause it. I'll be right back. All right, believe it or not, that took me forever to do all that highlighting. But anyway, I think it's going to help us in the long run. So I need to go ahead and do that. So it says, first part of this says, circle the ordered pairs that are solutions to the equation 2x plus y equals 10. Remember, a solution, each solution can be represented by a point on the coordinate plane. In other words, which one of these points belongs to this line? Now, it won't be necessary to solve for y in this case. Don't worry, your homework will not be like this. But they just want to know which, if I were to plug in these numbers in these specific spots, meaning if I were to plug in my x value here and my y value here, which ones would make it true? Which ordered pairs belong to this line? So I'm just going to do it inside my head, and I'm really, really 100% hoping that you guys have the audio on, because I have noticed that some of you guys are watching the videos without sound, and it's really bothering me. So I don't know what I'm going to watch. I'm done with y'all. Anyway, so first thing you want to do is you want to plug the 8, yellow for yellow, pink for pink. So 2 times 8 is what? 16 plus 2 plus y plus 2 is 18. So does 18 equal 10? Does 18 equal 10? No, that does not belong. I'm going to erase this. Okay. I don't want to show all the math for it, but I just wanted you guys to kind of know what I'm doing in my head. Next one is 2 times 4. So 2 times 4 is 8 plus 2. Is that 10? Yes. So this would be considered one of the points that belongs to this line. Let me re-highlight that. I know I'm like all over the place. Let's try again. 2 times 8 is 16, minus 6 is 10. This one belongs on the line. 2 times negative 2 is negative 4. Negative 4 plus 6 is positive 2. Does not belong. 2 times 5 is 10. Plus 5, 15. Does not belong. 2 times 0, anything times 0, 0. Plus 10 equals 10. Good. 2 times 5 is 10. Plus 0. Yes, belongs. 2 times 3.5 is 7. Plus 3 is 10. Well, I'm so glad I did that correct in my head. 2 times 1 is 2, plus 2 is 4. Does not belong. Okay? So solutions are the ones, solutions to the linear equations are the points that you could substitute the values for, and it would give you a correct answer. Let me see. It would give you the answer that's on the other side. Let's look at the next one. You do need to know how to plot these points. Now remember, the first number goes, or the first number is related to the x-axis. The second one is related to the y-axis. You do need to know how to plot a point, especially by tomorrow. So you always want to start at the origin. You always want to start in the middle. We have a positive 1, meaning we're going to go positive 1, positive 2. There's my point. I'm just going to go straight across. We have 4, negative 2, so positive 4. 1, 2, 3, 4, negative 2, down 2. Next one is 0, negative 3. When you have 0, you don't go left and right, but we are going to go down 3. Negative 1, positive 3. Negative 1, left 1. Positive 3, up 3. Negative 2, 1. Negative 2, left 2. Positive 1, up 1. Okay. I guess we can write this down. So I should probably write it down on the bottom. The first number will always tell you whether you're going to go left or right. The second number will tell you if you're going to go up and down. Okay. So we did negative 1, 2, 0. Are we going to go left or right? Right 2. Do we go up or down? No, because it's 0. So we'll leave it there. 3, negative 3. Right 3, down 3. 2.5 and 1. So 2.5 is halfway. So here we go, up 1. That one was the tricky one. Now they want us to, now they've given us the points and they want us to give the coordinates. So we got to find A. Here it is. Now, we didn't go left and right, but we did go straight up. So since we didn't go left and right, it's 0 straight up, positive 3. B, we went straight to the left, 2, so that's negative 2. We didn't go up or down, 0. C is over here. We already did B. C is over here, so we go left 3. We go right 3, positive 3. And then we go up 4, positive 4. D, we go left 3, negative 3. Up 1, positive 1. E, where is E? We do not have E. I'm missing E. All right, F. We're missing F. Let's say, okay. Where are we at? All right, E was supposed to be negative 4, negative 3, negative 4, negative 3. So we're going to go left 4, down 3. Here's E. F is supposed to be 0, negative 2. So we're not going to go left and right, but we are going to go straight down. G is supposed to be 3, -3. That means right 3, down 3. There's G. Okay. H, 1, -4. So we go right 1, down 4. Here's H. And then I. Here's I, which is 2, 4, right 4, +4. We don't go up and down, so there's 0. I guess there's no J. J is the origin. Write order pairs of the points found on this particular graph. Remember, the best thing to do is find a point on the line where it intersects perfectly on the grid, just like right here. So if we're going to label that order pair, we need to know how far to the left and how far up it went. So 1, 2, 3, 4, meaning if we went left, it's -4, and we went up 3, +3. This is a good intersection. Left 2, -2. Up 2, +2. Here we didn't go left or right, so it's 0. We went straight up 1, 1. We go right 2, we don't go up or down, so right 2 means +2. No up or down, 0. Okay. All right, so when you guys come into class tomorrow, we are going to practice manipulating or changing the 1 and the 0. See what happens to our line when we change that 1 to a different number, or when we change that 0 to a different number, and then you'll be getting your assignment.